During our development process, I work close with my colleague from the engineering department, engineer Pierluigi Avanzi. And so during our development, we worked on 3 different pillars in order to develop our project. So the first challenge, of course, has been to adapt our current Giotto Top to be able to receive the new technology. So in this case, we had to develop a PCB and a new holder. The second challenge was to decide what kind of software the new Giotto Top Teach will be able to handle. And the third decision was to how to ensure the compatibility of the new Giotto Top Teach across the entire line of the Bardiani valves. So the first challenge, of course, was to design a new PCB. So the PCB is an acronym for printed circuit board, and as you can see in my presentation, in the picture, is the control board with the green color. So PCB has function to collect all the electronic devices, all the sensors, all the communication, all the wiring, and of course, as the main function, is like the brain of the Giotto Top. And the second technology that we use in order to detect the position of the valves is a magnet. So the magnet is now fitted on the main pin of each valves equipped with the Giotto Top Teach. If we go like more in detail, the PCB holder has sensors positioned on the back of the PCB, and those sensors has the ability of reading the position of the magnet. So one of the main difference between our current design and the Teach design is that the target is now a magnetic target. So the magnetic target is able to create a magnetic field, and so the readers located on the PCB are able to read always all the position of the magnet. So the biggest development in terms of detection is the possibility of the new Giotto Top Teach to read constantly all the possible positions of the stroke of the valve. If we think for a moment to the current Giotto Top, we have a metallic cam, and we have inductive proximity sensors. So the information that this kind of arrangement can provide back to the PLC are just the position whenever the magnetic cam is in front of the inductive sensors. The new technology, the Giotto Top Teach, has the ability to have a complete reading of the entire stroke of the valve without any hidden position. So it's like a more accurate way to read the position of the valve, and of course is more precise, and in terms of safety provides a higher level of safety about the reading position of the valve. So in the front of the new PCB, you can see that the design is very familiar with the old one. So in the left top corner, we have the solenoid valves terminals. So are exactly the same quick connectors that we use for connecting solenoid to any electronic board. As you can see, in the development of the PCB, we decided to change a little bit our terminology. So in this case, in the middle port, we have MS. In the upper port, we have LL, and in the lower connection, we have UL. Those are acronyms for main stroke, lower lift, and upper lift. So as a Bardiani, we decided to move towards a more universal terminology. Main stroke, of course, applies to every kind of valve, starting from mix-proof, single seat, butterflies, ball valves, or any other valves can be equipped with IO-Link. And lower lift and upper lift, they are more connected to double seat mix-proof valve, standard, or PMO. If we look on the lower left side, we have a connector which has 3 pins. So this is dedicated to the external sensor, and external sensor can be used on a traditional mix-proof valve. Is always mandatory whenever is a PMO, pasteurized milk endurance mix-proof valve, or could be optional on the pressure relief valve BB ZS5. On the bottom right side, we have the terminals. So there are pins that have the function to connect the control unit to the PLC. In this case, we have 3 wires. So that means that we are looking at a IO-Link port class A PCB. In case is a ASI 3, ASI interface 3.0 PCB, we will see only 2 pins. If it's a 24 volt digital, we might see 8 to 10 pins depending on the version. So until now, we can say that we have we saw components that are quite similar to what we were used with the standard Giotto Top. So the first big difference, of course, is the USB Mini B port. So this port is a direct communication with the brain of the PCB, and can be accessed with a laptop and a connection. So of course, everybody who is familiar with PLC programming should have all the programs to be able to interact, of course, with the IO-Link. For let's say users that are not familiar with the IO-Link, I will suggest to download the Burkert communicator, and with a special cable, you can connect your laptop to the Giotto Top Teach IO-Link, and you can have a look at the parameters, functions, software, and all the data that this new Teach system can provide back to the PLC. Sorry. So one of the second revolution are those three red buttons in the front of the PCB. And those three buttons are usually called teach functions. So when we start our presentation, we saw that this system has the ability to read every single position of the total stroke of any given valve. So that means that I read all the position. So what I need to do, I need to tell to the system what are the points that are significant for each different valve. What does it mean? Seems like very complex, but it's very easy. So imagine that you have a valve DN50. And valve DN50, of course, has a closed position and an open position, which is different from the same valve DN65 or DN80 or DN 4 inches. So the system is able to read all the position of the magnet. So what we have to do, we have to tell to the PCB what are the closed position and the open positions that are significant for the valves where the Giotto top is sitting on. Okay, so we have two different ways to teach the Giotto top in order to explain, in order to set those important points. First one is a manual teach. So I can press T1 in order to set up the position number 1, T2 in order to set the position number 2. So the pressure is a pressure between 2.5 and 5 seconds, and you will see a light signal coming back from the control unit. So that's the manual thing, and require a little bit of knowledge about what the position means based on the valves that we are looking. I think the biggest innovation in terms of teach function is the possibility to use what we call it ATF, automatic teach functions. So there are 4 preset functions. The automatic teach function number 1 is designed for any valve with a rest position normally closed. So could be a single seat, could be a ball valve, could be a butterfly valve, could be a double seal valve. So any valve which has like a simple actuator, and the actuator in a rest position without any air provides a normally closed position. So the automatic teach function that need to be selected is the ATF number 1. In case we have any single seat valve including ball or butterfly, which the rest position is normally open, then we need to select the ATF number 2. The automatic teach function number 3 is dedicated only for our classic mixed-proof valve, in this case the model B925, aseptic or with the external CIP circuit, where the automatic teach function number 3 will cover also the upper lift and the lower lift operation of the mixed-proof valve. Last one is the ATF number 4, sorry. The ATF number 4 is dedicated only for mixed-proof valve PMO, also known as pasteurized milk ordinance mixed-proof. So we can say that developing this kind of project, Pierluigi Avanzi and I, we try to cover all the possible, all the current valves that are in the Bardiani portfolio. Of course, we had to get to a compromise. So the valves that are not covered by this system are the long stroke valve with a diameter equal or over the N80 or 3-inch. The reason is that this system can cover a stroke of 75 millimeter. So whatever valve is over 75 millimeter can be not used with the Giotto Top Teach, but of course can be used with the standard and current Giotto Top. A small limitation is on pressure relief valve, the ZS5, where we have the possibility to detect just the closed position of the valve. So the second part that we developed was the plastic holder. So the plastic holder is represent the bones and the structure of the Giotto Top. So the main function of the holder are to protect the PCB from any accidental contact, mainly with tools whenever we have to tight the screw of the Giotto Top Teach to put in position on top of valve. And as you can see in the picture, on top of the holder, we have a 360 degrees color indication, which is provided by 4 RGB LEDs that can combine all the possible colors. Last function, of course, is to protect the magnet during its travel from the closed position to the open position. What we have done during our development phase was to conduct some tests. So we made 2 different kind of tests. So we made an impact test. Impact test is kind of a simulation of a crash of the entire system, and that was tested up to 50 G. So G is the expression of the gravity acceleration. We tested up to 50 G. As well, we conduct a vibration test, and vibration test was performed up to 20 G. And as well, we tested different different kind of frequencies in order to be sure that the entire system can withstand impact and plant vibration. So one of the things that we had to take in consideration during the development of the Giotto Top Teach was what kind of software, or what kind of communication system will be made available for our customers. So right now the current standard is IO-Link port class A. Available upon request is the IO-Link port class B, and during the Q1, so beginning of the next year, we will release our version of the ASI interface 3.0, as well the standard communication 24 volt digital. So what is IO-Link? So, and why we developed the IO-Link? So The reason behind the development of the Giotto Top Teach is very connected with the IO-Link technology. So the IO-Link technology is a communication protocol which is an international standard. So you can look up with the number 61131-9. So the IO-Link is a communication protocol which is based to a point-to-point communication protocol. So from the PLC, I need just one cable that goes to one IO-Link device. Why is so? For many people that are like they know and they are using, the ASI interface, the IO-Link could be a step back on technology, because the ASI gives you the possibility to connect up to 64 valves on the same cable. And IO-Link require one cable for one IO-Link device. But the reason why there's this one-to-one relationship between the PLC and the IO-Link device is because the communication is bi-directional. So there's data going from the PLC to the IO-Link device, and there are data that are going from the IO-Link device back to the PLC. So it's a very advanced system where you have a lot of information going back and forward. So we can say that it's not like a passive system, but it's an active. So there's a live conversation, live communication between the PLC and the IO-Link devices. So before I mention difference between two versions of the IO-Link. So we have the IO-Link port class A and the IO-Link port class B. So both systems are exactly the same. As you can see, if you look at these two tables, the one on the left is for the IO-Link port class A. The pin number 4 is dedicated to the IO-Link communication, as well the pin number 4 in the right table. The difference is that on the IO-Link port class A, I have just one supply line, L plus, L minus. On the IO-Link port class B, I have two independent energy supplies. So one is for the devices and the other one is for the IO-Link. So there's the possibility to switch the electronic supply between what is the IO-Link communication channel and the devices that will be supported by the supply energy. So that's everything from my side. Now I will leave the space to Mr. René, and thank you so much.
Thank you, Andrea. Hello, good afternoon, good morning, wherever you are. Yeah, my name is René Bachmann. I'm from Burkert, responsible for one of our system houses, and we gained some experience with process automation and especially IO-Link over the last years. And I would like to go through with you a little bit within the world of automation communication, give you a brief overview of IO-Link, a little deeper than what Andrea told you a minute before. And we do like a deep dive or dive into some functionalities. It's just some examples to give you an idea what modern control valves are able to do, able to handle. Yeah, the world of process automation is getting more and more complex. As you can see here, you cannot even recognize the details. And this is also what we experience in the real world. Everything gets more and more interconnected. And as you may know, we as Burkert dealt or have been dealing actually more or less with the field level. Yeah, you know devices, you know subsystems, and we were forced, or we took the challenge to went up a level, to the control level somehow, and we also can supply systems using a gateway interfacing directly to the control level, like field bus systems and Ethernet systems, or even, which is kind of a trend, as you all know, cloud-based systems. And we also introduced something at the latest SBS show in Nuremberg about edge computing. So to get and process data from the field level without using a PLC, and do some pre-processing and also some supply of data to the cloud level, to do some analysis of data. We get into an example in some minutes. So let's take a closer look at the IO link level. So where do we come from? On the left-hand side, you see, like what you know it as 24 volt DC level-based control heads, control valves. So with a lot of discrete wiring, so binary signals, analog signals, lots of cables, lots of parallel running cables, and you need a lot of space. It's a time-intensive installation and testing, a lot of sources for errors. Then we moved up to ASI, which provides kind of clean-looking installation. You have one cable supplying digital signals in parallel, or on the same cable with a power supply. And so you get a minimal wiring of, also the connectors are easier, simpler, only 2 wires, which is much easier than, as Andrea mentioned, like 12 wires to a double seat valve. Oh, sorry. What you cannot do with ASI, so at least with ASI 3, there is something that is more expensive in the world of ASI 5 that can do more. But with the normal installations, ASI 3, you can just do cyclic data transmission of binary signals. There are some analog options, but you cannot process diagnostic data. This is one of the drawbacks of ASI, and the other thing is there is some kind of automatic addressing, but this only works if you replace a device in a running system. If you do a new installation, then you usually have to walk from valve to valve using a handheld device and adjust the address, going from 1 to 62. So this is not necessary for IO Link. Sticking with this, so the addressing, you don't need to put an address to an IO Link device. You just need to plug in the cable coming from the IO Link device into a port of the IO Link master, and you don't need to even open the cap of a device, of a valve. Just plug in the cable, and that's it. And now process valves are really becoming smart, because you can access the hidden data, within the valves. Most of the valves, most of the control heads have some data available in their storage, in their memory, but you cannot access them yeah, only by plugging in a PC or whatever, yeah. And via IO-Link, you can access all these data. So the real benefit is in analyzing devices and planning maintenance and things like this. I give you some examples of how valuable this can be in your life. So now let's take a closer look on or at an IO-Link installation. So we have different levels. In a typical installation, so we have the level of industrial Ethernet. In most installations, the backbone system running to the factory control system. And then you have one or more PLCs. And using these PLCs, you can interface to other field bus systems like Profibus or RC or CanOpen or DeviceNet. Or you can also use modules for PLCs that you can directly connect IO-Link devices to. So Siemens offers something like this. So you can plug in a control head like the Giotto to a card within the PLC. This is not the most commonly used way. In most installations, you will see the so-called IO-Link masters. Most come with 8 ports, so you can plug in up to 8 IO-Link devices. And they can interface, or there are variants available that can interface to field bus systems or directly to industrial Ethernet. The cables can be up to 20 meters long. Simple cables, not shielded, 3-pole cable with M12 connector. If you have port class B devices, as Andrea mentioned, then you need a 5-pole cable with another connector, but these come with the device. You don't need to worry about this. Yeah? You just need to have the right port at the IO-Link master, and then you just connect it, and no addressing needs to be done. You are up and running from the installation point of view. Of course, you need to do something on PLC level, on programming level. All sensors, actuators with IO-Link interface come with, or can be supplied with an IODD file. So this is something that I want to show you in more detail. So with the IODD file, which contains all important information, you can do quite an easy system integration. It comes with, this, thank you, very good. If you click on the link in the presentation, you get to the so-called IODD Finder, where you get detailed information about the devices. You just need to enter the manufacturer name, which I already did here. And then you see, for instance, port class A device. And if you select this, you get some basic information about the device. But then you can take a closer look. Yeah? And you see lots of data, like identification data, which will be filled in real life with the data coming from the device, so serial number, hardware version, and so on and so on. Lots of parameters, so it's a really long list. Yeah, we do not go into this right now. I can only cover today some examples that I will give you in a second. So, and you can go through this and also get some information, especially for the parameters. It might be interesting, some help, so that you see, okay, you can lock the buttons that Andrea mentioned. So if you want to prevent that anyone plays with the devices in the field, then the guy in the control room can tell the device, no, we don't allow manual interaction with the device in the field. I want to do this only from the control room. Then he locks the device. This is just an example. And now we go back to the presentation, and I can show you some details, yeah, of typical functions. Like Andrea mentioned the automatic teach functions, so he covered this in detail. This is how it looks when you dial in from the control room via a software that comes with the, or can be downloaded for an IO-Link master. It more or less looks the same for all available IO-Link masters. And you can go through several screens, through several data structures, and then you come to the point where you find the teach functions. And then you can activate this from the control room, yeah, or even from the PLC program. So this is up to the programmer who is responsible for this installation at the end user. So you can start the automatic teach function, and this can run, and at the same time the next and the next and the next can be activated. So instead of doing it step by step for every single device, yeah, walking up to every single device, you can do this without opening housing everything from the control room. Yeah, so we had the first installation in a big diary when we started with IO-Link, and the head of automation there told me, so he never had to go to one of the valves, yeah, to get the installation, the plant up and running, which was very good for him, yeah, so because you don't need to open a cap, you don't need to worry about seals that might be lost, something like this. Just do everything automatically. So another feature that might be interesting for some end users is to change the feedback colors. There is a factory setting. Of course, if you dial in, then you see, for instance, a closed valve will be shown as yellow, but you can change this. Yeah? You click on, as usual, on this tab, and then you can change, make it white or red or orange, whatever is available there. This is quite a fancy stuff, but yeah, for some users it's quite necessary to not confuse people in the field, yeah, about different colors for different manufacturers. So this is something which can have real value in terms of planning maintenance actions, things like this, or locating errors. It's called valve travel times. So it's an example here. If you supply the valve with 6 bar, the valve takes about 2.5 seconds to open. If you go down to 4 bar, it takes 3.2 seconds to open. So you see, yeah, and if you save the value at the point of installation, and maybe transfer the value to the cloud, and maybe if you have a really ambitioned plant operator or manager, then they can even use artificial intelligence to use anomaly detection algorithms to see if something goes wrong. Yeah, if sometimes go out of hand. Yeah, so if you, for instance, take 6 seconds to open a valve instead of 2.5, then something went seriously wrong. There's a leakage or whatever. Then you can plan maintenance actions or deeper analysis of the plant. This is just one example. There are different values available in such a modern valve. Another thing is you can take a closer look at the device status. It gives you an overview of the general health of control head, like the temperature within the MCU, so the microcontrol unit, or the supply voltage measured at the device, not at the power supply, but what really is available at the device. Operating hours, things like that. Yeah, quite useful information, boot counters and stuff like this. The list is quite long. Then again, something fancy, maintenance. You may all know there are some maintenance features that can be adjusted, like you want to get a notification if a certain number of valve strokes is reached, like 10,000 switching cycles, then you get, in this case, a blue light. Yeah, but you can also do this manually from the control room. For instance, if some guys tell you, okay, this and that valve needs maintenance, then the guy in the control room can activate the maintenance function. So manually set it to blue light, and then he can tell the maintenance technicians to walk up to all the devices showing blue light. And if they finished their job successfully, they can reset this, and then you see, okay, maintenance is completed for all the required devices. Yeah, this is what I wanted to show you. Thank you, and yeah, I hand back to Andrea.
All right, René, thank you very much for your presentation and for your insights on the technology. So let's now take more or less, we have extra 15 minutes where we can see if there's any questions, any doubt, or any clarifications that our audience might need from us. So yeah, the first question is, as your new Giotto 24 volt and as the protocols. Yes, Jim, thank you so much for your call. Yes, we do have our Giotto Top Teach in digital 24 volt and ASI interface 3.0. The official release will be in during Q1 of 2025. So we are now completing the IO-Link sales, let's say, and then we will start with the new year, completing the entire offer. Have you already made a forecast based on the requests that have already arrived? If so, from what sectors have these requests arrived, and how many IO-Link Giotto Teach you will keep in stock? Oh, okay, that's that's a very complicated question. So of course, yes. Let's say, and probably René can add something, but we have seen in the market in the last months a big interest of end users towards the IO-Link, especially on the IO-Link and Teach technologies. So the reason is, of course, the data and the diagnosis, and the fact that is a going back and forward communication system which allow customers to have safety about okay, my devices are working, I can get parameters and data. And so yes, we see, we have seen requests, we have seen activities and stuff like that. We do have stock of our Giotto Top Teach IO-Link Port Class A right now, and of course we are open to stock other configurations, ASI and 24 as soon the project will be completed. René, do you want to add something on the IO-Link? What do you think on the market? Expectations?
Yeah, maybe I can add something from our experience. So if you look if you click on the link, yeah, IODD Finder, you will see if you type in Burkert, you see about 50 different devices. Yeah.
Yeah.
And we've seen over the last years a tremendous rise in demands, especially in Europe, in North America. Yeah. It was a little slower in the beginning, but so it was introduced in Europe more or less, and then it went up everywhere. And we see, and also there's an official statement from the IO-Link community. It's I think it's an increase, a yearly increase of more than 20%. Yeah, so it's really gaining speed. Yeah.
Yes, thank you, René. Yeah, I was in the IO-Link day, I think it was September, and from 2002, 2022, there were like 25 million nodes active under the IO-Link. And in the middle of 2024, the IO-Link reached 55 million. So that's like a big increase on the IO-Link technology. So do we have other questions? Yeah. Is there safety output on IO-Link? I will ask the help from the expert. So, what do you think, René?
There is some so-called, I call it built-in safety aspect in the IO-Link technology itself. For control valves, you can use the port class B technology, and for most installations, it's a level of safety that is enough. Yeah, and you can turn off the second power supply. So what was given in Andrea's presentation with I think it's called 2L or L2. So the second power supply wire. If you disconnect this and put a switch for this power, then all valves go to the safety position, because all solenoid valves go to their mechanical safety position. And at the same time, you still get the reading. You still get signals from IO-Link. Is the valve open? Is it closed? Yeah, and this is a level of safety that is built in. Yeah, and if you look at different safety things, there are IO-Link safety masters available, but I think this requires some deeper level of insight.
All right, thank you so much, René. I currently have all the valves equipped with ASI. Why should I consider IO-Link for the next project? Yes, I think this is a very a recurring question right now in the market. So I guess I would say that ASI is a very reliable, and is a good way to connect valves in the process, even because there's a large number of valves, so ASI reduces the number of cable and wiring and stuff like that. So I guess probably the main reason behind a switch to IO-Link is to have feedback data, diagnosis data from each single device under the IO-Link. And one of the main benefit of data is the analysis of the data. So whenever you start having a lot of data on, opening, closing, strokes, timing, pressure, temperature, and length, an example that René did in his presentation, like you can on the same valve, like in a manifold, you can check if all the valves has the same stroke or they move at the same speed during opening. So you can detect if there's pressure, is there air pressure, or is there something else into the line. So it's like there's a lot of data, and of course data management behind IO-Link probably is one of the best and the biggest challenge, right? So René, what do you think?
Yes, you covered it very well from my point of view. Maybe we could add one aspect which I mentioned briefly. Installation time can be reduced because you don't need to open every single valve. Yeah, just install them, plug them in, and do the rest from the control room. Yeah, it
Yeah,
saves
that's true.
a lot of time. Yeah.
Yeah, that's true. That's true. So where can we download the service app to connect the module parameters? Is a special USB cable required? Yeah, so I was mentioning about the communicator. So communicator, I think is a free and open software that you can download, I guess, from Burkert website, and gives you the possibility to open a direct connection with IO-Link. Of course, there's other in the market, I guess. So that's mainly depend on what kind of system are you used. So what about René, the USB cable? You have any requirements?
Yes, it can be ordered as well, but if you just want to access the parameters of the Giotto Top, for instance, or any other IO-Link device, you can use the software that is available for your IO-Link master. If you buy something from IFM, for instance, they supply a software, and then you don't need to open the cap. It's just for special services, for firmware update, something like this. Just to access the parameters, you don't need to open the device, use the IO-Link cable, use the software for the IO-Link master, and then maybe you get a very brief training from IFM or Turk, whatever is your preferred
Yeah,
supplier.
yeah.
Yeah, and then you can just access all the parameters that are also available via the USB connection. Yeah,
So
it's easier.
you mentioned René that there's like you mentioned different producers, of course, manufacturer of IO-Link devices. So do you think that having like an open standard as the IO-Link and to share around those manufacturers is one of the key point of why this technology is like growing so fast? What do you think?
Yeah, that's true. That's true. And if you go to Google and type in IO-Link, yeah, then you easily get a list of IO-Link master suppliers. The most commonly used are IFM, Torque, Balluff, Siemens. Yeah, Siemens is more integrated. Yeah, if you don't want to put IO-Link masters in the field, then you can also install them in your cabinet next to the PLC. And so there is a variety of master suppliers, and exactly, Andrea, this is a reason why this technology is is rising. Yeah, because you can select from different suppliers.
All right. So I guess we have another question. Maybe it should be the last, since we have like 2 minutes left in our webinar. So how can the implementation of IO-Link technology support the digitalization of industrial processes, and what benefit does this offer in terms of operational efficiency, cost reduction, research? Oh, okay. There was a question that in part we answer. So in terms of cost reduction and resource optimization, I mean that's like a question a little bit complicated. I think is like more related to the let's say process um, situation or structure that every customer has. So of course there's cost probably. I don't know, Rene, if you had experience, but probably there's cost on training of people about the new technology, and there's like more cost on technology, like on CPUs and digitally. So what do you think?
Well, there are different aspects, or if you look at this from different angles, then you might get different answers. If you look at this from installation point of view, IO Link is very easy, because you don't need to worry about addressing. It's just everyone can do this. Everyone, a skilled worker or someone who has received the training, especially in the US or things like that, then you can tell them, okay, plug this into this port. Done. But on the PLC level, it requires, of course, some experience, but it's a standardized technology, very well documented, and people used to program PLCs know how to deal with this, especially also using details that you can get from the IODD Finder platform. You can download the files and they get very easy access, and that's why it really supports the digitalization very good, in a very good way, because it makes life easier because of the standard that is behind. And this in itself leads to cost reductions. You have less trouble during installation because it's easy plug and play, from a installing point of view. And then if it's standardized and the data structure is very well documented, then it's easy to do the programming. No, if you go back to the world of Profibus in the beginning, for instance, you had to know, okay, bit 0 is whatever, and then it was very difficult
Big
to
manual.
a big manual, and then you have to
Yeah.
know, okay, which order the bits are arranged, and some people did it like this, and then it didn't match,
Yeah. Yeah.
and this level of standardization with IO Link is much better now.
Yeah. All right. So Rene, thank you very, very much for being our guest of honor today on our webinar. Of course, for everybody that attend our meeting, our webinar, thank you so much. And if you have any question, any doubt, feel free to reach out to me, Pierre. Your user representative should be able to assist you. And yeah, for me is everything, and hope to see you soon on our next webinar. Thank you, Rene.
Thank you. Bye.
Have a good one. Bye bye.